rate of return of a project is the rate that will give a net present value of 0. Let's look at the internal rate of return. The internal rate of return. Now, what is the internal rate of return of a project? What is the internal rate of return of a project? Now, the internal rate of return of a project is the rate that will give a net present value of 0. So it's basically a rate when applied to a project. So when I say a rate, the rate is a rate, and the rate is a percentage. It's a percentage. So a rate is a percentage. And this percentage, when applied to a project, should make the NPV equal to 0. So the internal rate of return can be expressed as simply as looking at the NPV formula. We can say the internal rate of return is when the NPV, which was seen as the summation, which was looked at as the summation. So the NPV was looked at as the summation. So this one sums here n, then the time t at 0, the summation of the present values of the cash flows, 1 plus r exponent n minus the initial investment should be equal to 0. So this is the basic definition of the internal rate of return. So when we look at the particular rates, to be used here, the entire NPV or the project should give us 0. So that is the internal rate of return. But how do we find the internal rate? How do we find the internal rate of return? Now the internal rate of return, IRR, is found using the formula A plus to bracket. So let's use the NPV of A all over the NPV of A minus, into bracket, minus the NPV of B okay, the NPV of B multiplied by B minus A percentage. So here is also a percentage. Now the reason why I've stated this as minus, in some books you also see it as the internal rate of return is equal to A as a percentage plus So let me open a bracket. So here is the NPV of A over NPV of A plus the NPV of B times B minus A, all exponents, bracket close, percentage. Now when we know that when two negatives meet, it should give us positive. So in some books they will write the formula as this, in some books they will write it as this. They are the same. Now let's go on and take an example and find the internal rate of return. So let me write the question here. Use the question here. Okay, so let me do this. So we have year, and the cash flows, which are in dollars. So we have 0, we have year 1, we have year 2, and this one is 10,000. Sorry, this here is $10,000. The second is $6,000, and the third is $8,000. The cost of capital is 10%. Now let's find the internal rate of return, or the rate at which the NPV will give us 0. So let's use a simple table. Let's use a simple table. So we first start with the year. Let's start with the year. Then we look at the cash flows. We look at the discount factor at 10%. Then we look at the present values. Okay, now let's start. Now this is the year, this is the cash flows, this is the discount factor at 10%, and this is the present values. So let me create year, sorry, so this one will be year 0, year 1, and year 2. So for year 0, initial investment of $10,000 was made. Year 1 we got a cash flow or return of 6,000, and year 2 we got $8,000. We got Now we have to find the discount factor at 10%, and this one will give us 0.909, 0.826, and 0.751. Okay, then after that we multiply the discount factors by the cash flows to find the present values. So the first year will give us, oh sorry, in year 0 the discount factor will be 1. Because 1 over 1.10 exponent 0 is going to give you 1 when you punch it on the calculator. This one will give you 0.909, and this one is 0.826. Okay, now this one, when we multiply 1 by 10,000, we are going to get 10,000. Then 6,000 times 0.909 will give us 54 as we calculated already. Then 0.826 times 8,000 will give us 6608. Now after getting this, we need to find the net present value. So the net present value, what is the net present value? Is the addition of this plus this plus this minus this one. So 54 plus 6608 will give us 12062, minus 10,000 will give us 2062. Give us 2062. So at 10%, we got a positive NPV. So in order to find the internal rate of return using a positive NPV, using a rate of 10%, we had a positive NPV. Therefore, we have to increase this cost of capital 10% in order to get a negative NPV before we could calculate or can calculate the internal rate of return. So let's look at a discount factor. Let me use a different. So let's use a discount factor of say 20%. Discount factor of 20%. So a discount factor of 20%, then we are going to have the present values. So when you look at the discount factor of 20% for year 0, you are still going to get 1. Now a discount factor at 20% for year 1 will give us 0.833, and for year 2 is going to give us 0.694. So if you want to find for year 1, it's 1 over, it's going to be 1 over 1 plus 0.20 all exponent 1, and this one will give us 0.833. Now let's find the present values. So here is going to be multiply the 1 by the cash flows here. So here is going to give us 10,000 Then 0.833 is multiplied by 6,000. So 0.833 multiplied by 6,000. And this one will give us 49.98. 49.98. 0.694 times 8,000 will give us 55552. So here we have to find the net present value. The net present value. Okay, so let me put that here. The net present value. The net present value is the summation. The net present value is the summation of this plus this minus this. Okay, so sorry. So when we add 499.8 plus 5552, we are going to get 10,000. We are going to, okay, so if we subtract, we are going to get 10,000. This plus this will give us 10,550. And so when we subtract 10,000, we are still going to get 550, which is not negative. And so we have to still increase this rate to a rate that will give us negative here. Therefore, we have to look at a different rate. So when you are calculating the internal rate of return, it is called the try and error. Try and error method. And when we use 20%, we have gained another positive figure, which we don't need. We need a negative figure. Therefore, we have to go back and choose a different rate in order to get a negative figure. Okay, so let's go and choose a different rate. So let me go here and extend this line. It will help us. So now let's use a discount factor of 30%. So this whole thing is wrong. We cannot use this one. So we are now finding a different discount factor. At 30%, we are going to have 1 here, because the discount factor 1 over 1 plus 0.30 exponent 0 will give you 1. So we are going to have 1. 1 over 1.30 exponent 1 will give us 0.769, and for year 2 we are going to have 0.592. When we multiply this by these cash flows, we are going to have present value. We are going to have 10,000 here. Another one will be 769 multiplied by 6,000. That one will give us 4614 and 0.592 multiplied by 8,000 will give us 4736. Now when we add this plus this and subtract this, we will get the NPV. So this is not accepted. So the NPV So the NPV is equal to 4736 plus 4614, giving us 9350. So 9350 minus 10,000 will give us 650 negative. So we can go on and calculate the internal rate of return. I've told you that the internal rate of return can be computed. So let me clean here. So the internal rate of return is A percentage plus the NPV of A over NPV of A plus NPV of B times B minus A, or percentage. Now what is this A? The A is the rate that we used, of which we got a positive NPV. So A equals to 10%, and the NPV of A is the net present value, which was positive, so 2062. Then B is the rate that we use, of which we got a negative NPV, and that rate is 30%, so 30%, and the NPV of B is 650 minus. So this implies that the internal rate of return equals 10% plus 10% plus 2062 plus 650 times 30 minus 20, 30 minus 10 percentage. So in order to compute this one, you have to calculate what is in the bracket first. So what is in the bracket will give us 2062 plus 650, give us 2712. So 2062 divided by 2712, and this one will give us 0.760. So here 0.760. Then we're going to multiply that by 30 minus 20 is 20, so we are going to get 15. So we are going to get 10% plus 15.206%, and this one should give us 25.206%. So the internal rate of return is 25.206%, or we can say 25%. Now this is the rate. If we apply on this project, we'll make the NPV equal to 0. Calculated the internal rate of return as 25.206. Let's assess whether our answer is right or wrong. So I stated that it's the rate at which the NPV should give you 0. So let's use 25.21% here. So let's use this table. Okay, so this is for year 0 and this is for year 1. So let's look at the years. the cash flows. So here, cash flow, PV, the discount factor. So let's use a contrasting color, which is the year, which is year 0, year 1, and year 2. We have the cash flows, the discount factor, which is here is the discount factor 25.21%. let's use that. Then the PVs, and see whether we are going to get 0 at the end. So here is 10,000, here is 6,000, here is 8,000. Now here will give us 1, because 1 over 1.2521 exponent 0 will give us 1. Now let's look at the discount factors for year 1 and year 2. So 1 over 1.2521 exponent 1 will give us 0.799 using 3 decimal places. And for year 2, we are going to have 0.638. So when we multiply by the PVs, or by the cash flows, we are going to get 0.799 times 6,000 will give us 47.94, and this one will give us 10,000. Then 0.633 times 8,000 will give us 50.64. Now 47.94 plus 50.64 will give us 98.58. So when we subtract 10,000, we are going to get like 142. Now we are going to get a figure which is 142, because we've rounded the decimal places. So when we take the decimal places as far as it can go, it is going to give us 0. So the positive figure that we had here is as a result that we've rounded the decimal places to 2 decimal places. But if we want to go as far as the decimal places can give us, we are going to get 0. Hope you understand. Decision rule and internal rate of return. Look at the decision rule. Now the decision rule and the internal rate of return is that if the internal rate of return calculated is greater than the cost of capital used for the investment appraisal, then we should accept the project. But if the internal rate of return is less than the cost of capital, then we should reject. Okay, let me explain this. Now, the internal rate of return is the rate at which the project NPV is equal to 0. That is, neither the project makes profit, so it does not, neither does it make neither profit or loss, meaning the project breaks even. So this rate is what makes the project break even. Now let's use our example that we did earlier on. The project cost of capital was 10%, was equal to 10%. But the internal rate of return computed was 25.206%. On the basis of this, should we accept the project or reject the project? This one is saying that if the internal rate of return is greater than the cost of capital, then accept the project. So under this condition, we are going to accept the project. But let's look at the intuition. Now the intuition is that the cost of capital is the return that investors require on their investment. Okay? So if investors require a return of 10%, and the project, even if it does not make profit or loss, can return 25%, it simply means that we can get the 10% that investors want and still retain 15% as excess return. Therefore, the decision rule means that even if the project does not make profit and can still make excess of the cost of capital, then the project is worthwhile. That is the intuition. Okay, so now let's look at some advantages and disadvantages of the internal rate of return method. So let's look at the advantages and disadvantages. Now, the advantages of the internal rate of return is similar to the advantages of NPV method. One, it considers time value of money. So it discounts the cash flows into its present value. It is based on cash flows, not accounting profit. 3, it is simple to calculate and easy to understand, because it gives a percentage return, which in this case was 25.201. Then the internal rate of return will give the same decision as NPV. Give the same decision as NPV. But it has its own disadvantages. One is it is a relative measure. When you say it's a relative measure, it means that it ignores the absolute size of an investment. So when you look at let's say two projects, let's say project A and project B, which this one is 15% and this one is say 20%. The internal rate of return is 15% and this one is 20%. Which of these projects is better? In the normal sense, you say 20% is better because the project breaks even at a rate of 20. In the normal sense, you say that the project breaks even at a lower, this one is better. In the normal sense, 15% is better because the project breaks even at a lower rate. But it ignores the size, size of the project. It ignores the size of the project. And so it's a major disadvantage of this is a major disadvantage of the internal rate of return. The internal rate of return method of appraisal gives incorrect answer when projects are mutually exclusive. When projects are mutually exclusive. So if there are two projects, say project A and project B, and management have to decide between these two projects, the internal rate of return calculated will give a different answer and lead management to make improper choice based on internal rate of return calculated. Another disadvantage is that the internal rate of return does not indicate how much an investment will add to the company. So it does not indicate the value that will be added to shareholders' wealth. What this means is that when you look at the NPV approach, you realize that we get a precise figure, a dollar amount that will be added to shareholders' wealth. But the internal rate of return gives a percentage. So it does not give the precise amount that shareholders will get when they undertake